Hello, this video will be a beginner-friendly tutorial on how to emit rigid bodies into simulation, but not just any rigid bodies. I want those rigid bodies to be breaking as well. So yeah, let's start. To begin, I'm going to use a geometry container because we need some geometry to break actually, or to emit. Let's do this with a torus. Why not? So just a basic torus. I'm going to make it a little bit more thin because I prefer it that way. And put it up about 1 meter up into the air, something like this. To make this into a rigid body object, all I need to do is use an RBD configure node. Configure, put it down. And now this torus, which consists of a lot of points and primitives, gets packed into one little object. And I'm going to show you this in the next way. By default, this is set on build. The user interface is set to build. We can put this to technical, but then we get a lot of extra screens. But the only thing that I want for now is the geometry spreadsheet, and I want this open all the time for now. So because I don't like to skip ahead and go back and every time. So what I'm going to do is here I'm going to put this little triangle, this little icon over here, pane tab operations, and say split pane top bottom. And here now in the bottom I'm going to drag this tab over here next to the scene view, move the scene view, and now I've got this geometry spreadsheet open, and I can keep it open all the time. So this was my torus, which as you can see has a lot of points, but only position, no other attributes, and it's got a lot of primitives as well, polygons here, nothing, no attributes there. But if I use the RBD configure node, then it becomes one packed object, and it's got a couple of extra attributes. It's got bounds, density, and a name. This is because this is much easier for the simulation to calculate than over all these points and all these primitives. So to do this, to actually use a simulation, the next step that we're going to need is a RBD bullet solver. The bullet solver, but before I push this down, I click this somewhere in my network, I'm going to click it right over the bottom three points over there. So you see those little lines already connecting. And if I put this down, every thing is connected. But what is it that's connected? Well, the first output here is the geometry. It's the high-res geometry. The second one is the constraints, in case we have any constraints. And the last one is proxy geometry. So this proxy geometry is what's actually getting used to calculate the movements inside the RBD bullet solver, if it's connected. If it's not connected, it actually uses the high-res geometry. But it is connected now, so it's that's being used. So if I'm going to play this now, well, it's going to work, but it's not very interesting because my torus is falling down, and it's going to fall down ad infinitum. And well, that's not very interesting to see. So what we're going to do is inside the RBD bullet solver, there's already a collision tab. And in the collision tab, I'm going to say the ground collision. I do this by a ground plane. So now we've got a ground plane. If I go back to frame 1, and if I'm going to zoom out a little bit and I play this, it will fall onto the floor. Not very interesting still, because it's just falling down and it's just going to sit on the floor for now. So the next thing I want to do is give this torus some initial velocity. And I can do this in a couple of ways, but one of the ways that I like to do this is by using an attribute randomize. Attribute randomize, where are you? Here you are. And I'm going to put this down, and I'm going to use this in this chain, in the proxy geometry. So, because as I said, this is what's being used to calculate everything. By default, it's set to CD, which means color. But I am not interested in the colors, I'm only interested in the velocity. So I'm going to put a V in here, a small v, not a capital. And the values that are being created, it's a vector, so it's got 3 dimensions. And here it's the minimum value and the maximum value for the x, the y, and the z axis. This one gets ignored. So the minimum value, let's say about -5, maximum value 5. I want to push it up a little bit into the air, so this I'm going to say about 2, and maximum, I'll say 5 as well. And for the z, -3 and 3, something like this. Doesn't really matter. Now I'm gonna hook it up, connect it, and if I play this now, it will get an initial velocity. Voila. So far, so good. Next thing, this is only one torus. I wanted to have more toruses. So the next thing that I'm going to do is I'm going to say, okay, I need more toruses. I want to use this as an emitter. So the RBD configure node has got one little tick box over here at the bottom, emission, RBD bullet emit. Push this on. And in the RBD solver, in the setup tab, there's also an RBD emit that I have to push on. And now it will, every frame, it will make a new torus. So, even though this might look nice, not really what I wanted. First of all, there's a couple of things that are going on. They're really emitting an awful lot of toruses. And one of the other things that I think is strange as a beginner is that all the toruses are moving in the same direction. And I just said I want to randomize the velocity. So why is this? Well, the reason for this is because the input geometry here doesn't change. The torus doesn't change, the RBD configure doesn't change, and this attribute randomize, it gets the same input. So it automatically, doesn't matter if I say randomize, it automatically makes the same random numbers given these values for every single frame. Because if I look at this and I can go through every single frame, the velocity here stays the same every single time. To change this, what I need to do is I have to change the seed. And to do that, I'm going to go into the options tab here. There's a global seed here. And here I can change this to, for example, $FF, so the floating frame value. Every frame, there is a new value for the seed. Because if I click this and I go through, it will say 1, 2, 3, 4, 5, etc. And you can already see here at the bottom that the velocity gets changed every single frame as well. So if I go back to this now, and I'm going to emit, now all those toruses are going into a different direction. But there's still way too many. So in order to fix this, what I'm going to do in the RBD configure node, instead of the emission, the RBD bullet set to 1 here, I'm going to use a little expression here, and that's going to be $FF, so for the floating frame number, and then modulo. That's a percentage sign, and then modulo, let's say every 10 frames, modulo 10, equals 1. What does this mean? For people who did not pay attention in math class, you can subtract every the number that's behind the modulo, behind the percentage sign. The frame, you take the frame number and subtract as many times as you can, 10 from it, until you've got the smallest number possible above 0. So that means that if I have a frame, let's say 5 or 6, for example, if I click on this now, it says 0. So the expression here results in a 0. Why in a 0? Because frame 6 modulo 10 is not equals 1. Frame 11, however, this does result in a 1. And the same goes for frame 1. So frame 1, frame 11, frame 21, every time there is you can subtract 10 number of times you want, and the remainder is 1, then this will equal 1. So what does this mean? This means that every 10 frames I will be emitting a torus. So let's do this. Then, okay, as you can see, here we go. Well, it's already a little bit better, but still I'm not happy. Because I think they are a little bit boring the way that they are emitting. They all move in, they're flat, they all move in the same direction, or not the same direction, but they don't have any rotation in there. And to do this, to add rotation, I'm just going to alt drag this attribute randomize node, and I'm going to put it in the bottom here. But instead of the attribute name V for velocity, I'm going to use W, and the W actually stands for rotational value, rotational speed. And this is, I think, in degrees per second, but I'm not sure. It might also be in radians. I'm not 100% sure, but well, we can look it up later if we want. But we're going to put in some values. They have to be a little bit bigger than this. So let's say minus 15 and 25 doesn't really matter. 10 and 20, or minus 10, minus 20 even, whatever. And let's say this minus 15 and 15. Just something like this. And now if we're gonna, this might be a little bit exaggerated. Number is a little bit too big. So let's tone it down a little bit, minus, make this 10, and I'll put this on 15. Maybe this gets a little bit better. Yes, this is a little bit more what I want. So now every first 11, 21st frame, so every 10 frames I'm going to say, it gets a new torus gets put into the simulation, and it will rotate and move into a certain direction. I do think that I want a little bit more velocity, so I'm going to up these values a little bit. So let's say minus 8 and 8. I think it's a little bit boring, so let's make this 3 and 7. And make this minus 5 and 5, something like that. Not really important for now, but yes, this is a little bit better. All right. So the next thing that I want to do is I want to break all these toruses. To do this, well, I could do this by hand, but I'm very lazy. So I don't like to do a lot of things by hand if I can do this with the push of one button. So what I'm going to do is I'm going to make this one my actual, the node that I'm actually seeing and actually that I've selected. And now I'm going to go into my model tab over here, and I'm going to shatter. What this does, it makes 3 nodes for us. I'm going to rearrange them a little bit so it is a little easier to see. It adds 3 nodes, these 3 nodes. And those 3 nodes are an ISO offset, which makes a fog volume of the incoming object. And then there is a scatter node that scatters a couple of points in the fog, so inside of the object. And then there's a Voronoi fracture node that does the heavy lifting, and the points that are getting in there will be the center points for the chunks that it makes. You can already see this by the lines, but there's also a possibility to show this with an exploded view. If you look at this, here you can see these are the chunks that are being made. So pretty cool. I don't need it, this is just for view, so I'm going to delete it again. So now I've got this Voronoi fracture, my RBD configure node, and everything. Oh, let's keep this a little bit tight. Yes. Go back to frame 1 and have a look at this. So now if we're going to play this, this is what we're going to see. Oh, wow, this is interesting, but it's not really what I wanted, because now they're already breaking up the moment that they are emitted. Why is this? Because the RBD configure node is getting input from the Voronoi fracture node, and this Voronoi fracture node already, as we can see, is already got a lot of chunks in here, as we saw earlier with the exploded view. So what it does, it makes different pieces, piece 0 to piece 9, so that's actually 10 points, the 10 points of the chunk centers. So this is correct, but every single time that I'm going to do an attribute randomize now, every single chunk gets a different velocity. So, well, this can be interesting if this is what you want, but this is not what we wanted. So there is a possibility to fix this, is instead of randomizing the point, the velocity and the rotational velocity by for every point, I can say I'm going to do this for every primitive. And now here we go. There's on the on the detail. I mean, sorry. If I go on to this one, attribute randomize. Now I've got a velocity over here on the detail. So for this whole thing, I've got one velocity now, and for one value for the velocity, and I can do the same for the W. So instead of points, I'm going to say to detail. So now the velocity and the rotational velocity are on the detail. And this, now, what I can do is I can do attribute promote. And now I can promote these attributes back from detail to point. So, and which ones? Original name, velocity, and this one, both. So now they're gone here, but they're back on here, and they've got every single one that's got the same, as you can see. So that should be working. All right. So let's see. No, still not working. Why is this not working? Well, it's better, but it's still, they're already breaking up. So all those chunks, they don't stay together. Because even if they have the same initial velocity, that's because the rotational values that I gave them, they are calculated from the center point of each piece. So it's not that they are calculated from the center of the whole torus, but from every single piece. So they already, if I would remove this one, the rotational velocity, here this one, because I don't have it anymore, now they should stay a little bit better. Yes, see, up now they only break here. But because the rotational velocity that I added is calculated per piece from around the center point of this piece, it already breaks up. So yeah, that's not really what we wanted. So the next thing that we want to do is to make all those chunks of every torus glue together. Well, there's a possibility to do this, but just like before, I'm lazy. So I'm going to use something. Instead of making the calculations myself or putting down all the nodes myself, I'm going to use a little, well, I can't really call it a trick, but I use a shelf button. So what I'm going to do is I'm going to put this back on Voronoi fracture node, because this is the geometry that we're going to use, and go back into object level, and then here in my rigid bodies shelf there is this button, RBD glued objects. If I push this, then an auto DOP network will be created, as you can see, with all the nodes in there that are necessary to do this with a DOP network. But I don't want that, so I'm going to delete this. Yeah, but you just created this. Yes, but bear with me for a second, because inside the geometry node there's some stuff that has been created as well. I'm going to make it a little bit bigger so it's easier to see. We started with this, with the Voronoi fracture. It put down a rest node. That's we'll talk about this in another episode. But then it assembles and it sends this to DOPS. And here, this is actually what's interesting for me, for today at least. It's the connect adjacent pieces node and the constraint attributes that are being created. This is, these are the constraints. There's also a DOP object name prefix that I don't need. I can delete this. I can delete these as well, because I'm not going to use these. I'm going to use this part that I already had. The DOP import node here I can delete as well, because the whole DOP network, I deleted it, so this is never going to work. So what I have to do now is just set everything up. So instead of going from the Voronoi fracture straight into the RBD configure node, I'm going to go from the rest node here. And the constraints, as we saw here, oops, that's here, the constraints that are being put in here, this is the ones that we're gonna use. Now you can say, but hey, Rudy, there's also in here, if you look in here in RBD configure node, there's also a constraint node here. Yeah, okay, I'm gonna show you what this does. If I'm gonna put this on, there's gonna be some pin, it says to glue, and if I'm gonna use this now and I'm gonna play up, nothing happens, because everything gets pinned as well. And then you can say, oh yeah, but in the constraints I'm going to have to say break the constraints when they are glue pin. These ones I need to break them, and break them, when do I break them? For example, on a minimum threshold of let's say 0.1, but still nothing is working because they are pinned, and this is not what I want. So I'm not going to use these constraints. I'm going to use the constraints we just created. So instead of this, I'm going to just push this in right over here. So now if I go back to frame 1, and if I'm going to play this, then everything stays together, poof, with the rotation, and the moment that they touch the ground, poof, that's where they break. This is the way I wanted it. So I hope this has been clear. The main takeaway, I hope, for this tutorial is that sometimes it's easy to use the shelf buttons to do some things that you know work, because those shelf buttons are made for this, so you can learn Houdini easier, faster, because they already set up certain stuff. And for example, all these attributes here, constraint name, constraint type, and the propagation rate, these kind of things, those are pretty hard to remember, especially if you're a beginner. Then you will never be able to come up with those things just by reading the documentation, maybe. But those shelf tools, they really help, because it puts down everything in the way that it's expected to work. So this way it works. So I hope this makes sense. I hope you learned something, and if not, then well, maybe the next one. All right, have a nice day. Bye bye. Oh, and as an encore, I forgot something that I think might be interesting. For now, when it's simulating, every single torus breaks up in the exact same chunks, exact same size. And I want to be able to randomize this as well. So to do this, what I can do is go into the chunk centers here, and the total count here, I can randomize this. I can do this with an expression. I can, for example, say first rand $FF, because that's the seed. And what this outputs is a number between 0 and 1, but we don't want 0 and 1 as a number of chunks, because 0 chunks will never work, and 1 chunk, it's yeah, it's just the whole thing, so that's not gonna work. So we're gonna have to put in a minimum of, let's say, 2 or 3, and a maximum of, yeah, whatever you want. To do this, I'm going to use another function around this. It's called the fit function, fit01. And what this does is it takes an input number between 0 and 1 and transposes that into the new minimum and new maximum value that you put after the input. So the input is the random $FF, which is the number between 0 and 1. Then the new minimum will be, let's say, 3, and the new maximum, let's say, 14, something like this. So now every single frame, this torus will be broken up into a different number of chunks. So if I do this, and now I play this, we'll see that some are broken up into bigger points, so every time the chunks are different. So yeah, I thought that was a nice thing to add. All right, that's about it. Now really bye.